Good morning, ma'am. I am Pravalika and I am here along with my teammates Chanapala Syamini and Sheikh Shabina. We are currently pursuing our studies at RGKT Ongole, and today we are excited to present the outcome of our internship project, which we completed at EMERTXE, a renowned training institute in embedded systems. The title of our project is Washing Machine Simulation, an application of embedded systems. This project is a simulation of a real-life washing machine, and through this we applied the embedded systems knowledge we gained during the internship. We used the PIC16F877A microcontroller for programming and PICSIMLAB software to simulate our design virtually without the need for physical hardware. And the next slide is things we learned from internship. Throughout this internship, we received both theoretical and practical exposure to embedded systems. We started with C programming, what is the foundation of embedded software development. We practiced working with loops, conditionals and operators, arrays and pointers, functions and strings, and also storage classes, which are important for managing memory efficiently in embedded code. We are introduced to embedded systems architecture, understanding how software interacts with hardware. One of the major highlights was learning about PIC16F877A, an 8-bit microcontroller that we used in our final project. To develop our project, we used industry standard tools, MPLAB for writing and managing our code, XE8 compiler for compiling C code into machine language, PICSIMLAB to test and simulate our design. And the table of the contents. To give you a clear idea of our presentation flow, here is the agenda. Introduction to embedded systems components and applications, programming, project components, project requirements, implementation and demo. By the end of the presentation, you will have a clear understanding of how embedded systems apply to day-to-day appliances like washing machines. Introduction to embedded systems. An embedded system is a special purpose computer system, unlike a general purpose computer, which can perform multiple tasks. Embedded systems are designed for a specific function. For example, in a washing machine, the embedded system controls water flow, drum rotation, and buzzer alerts based on user input and programmed cycles. The system consists of software components. Hardware components like microcontrollers and sensors. Software, the code that drives the machine's operation. Once programmed, the software is stored in memory and remains unchanged unless updated. Examples of embedded systems are all around us: microwave ovens, ATMs, elevators, traffic lights, fitness trackers, and so on. Components of embedded systems. Embedded systems are built using a mix of hardware and software components. Hardware components include microcontroller, microprocessor, the brain of the system. In our case, we use PIC16F877A. And the next one is memory. The temporary memory for data, which is RAM, and permanent memory for firmware, which is ROM or flash memory. And next one is input devices. Sensors, switches, and buttons that detect condition. These are the input devices. And the next is output devices like motors, buzzers, and our LCDs that respond to system decisions. And we also have communication interfaces, protocols like UART, SPI, and I2C for data exchange. We also have power supply deliver stable voltage to run the system. Software components also include firmware, embedded C code that controls the hardware behavior. Device drivers allows the software to communicate with hardware ports. And the RTOs, real-time operating systems, used in complex systems to handle multitasking within strict time limits. These components work together to make the system reliable, compact, and task-oriented. And the next is the block diagram of the embedded system. This slide shows the basic block diagram of an embedded system. At the center is the system core, usually a microcontroller or processor. It receives inputs, processes them based on the program, and sends outputs. Input ports. Sensors or switches sends data or signals into the system. Memory stores both data and the embedded program. Output ports controls components like motors, LEDs, buzzers, or displays. Other devices. This includes communication modules, timers, or ADCs or DACs. All these blocks are interconnected and controlled through the embedded software that resides in the system core. And the next is the applications of our embedded systems. Embedded systems are used in almost every field due to their efficiency and dedicated functionality. Let's look at some real world applications. And the first one is consumer electronics. Washing machines, refrigerators, microwave ovens, smart TVs, etc. And we also use an automotive systems like which are used in airbags, automatic braking systems, and in engine control units. And in also medical fields also we use embedded systems. We use devices like glucose monitors, pacemakers, or infusion pumps. In industrials, these are used in robots, assembly lines, temperature controllers. This embedded system is also used in aerospace and defense, navigation systems, drones, flight control systems. The reason they are widely adopted is because embedded systems are compact, low cost, power efficient, and reliable for special tasks. Embedded programming will be explained by my mate. Over to Shabina. Thank you.
Now I'm going to explain about embedded C programming, which we have learned in our internship. Embedded C is an extension of the standard C programming language with additional features and libraries to directly interact with the hardwares like microcontrollers, sensors, displays, etc. Here are some key features of embedded C. First one is hardware access. Embedded C allows direct control of hardware through registers and ports. We can read sensors, control motors, or blink LEDs using specific memory addresses or bits. Efficient memory storage. Microcontrollers often have limited RAM and ROM. This embedded C helps to write compact and optimized code that fits in a small memory. We can manage memory manually and avoid unnecessary usage. Real time performance. Embedded C ensures low latency, which is crucial for real time systems like alarms, medical devices, or washing machines. Bit level operations. We can control individual bits of a port or register, useful for setting and clearing specific pins without affecting others. Portability. Most embedded C code can be moved across microcontrollers with a small changes. If we write modular code, we can reuse it for different projects or hardware. No OS dependency. Unlike high level applications that need Windows or Linux, embedded C runs directly on the microcontroller. This makes it lightweight and fast. Code structure. Like normal C, embedded C supports functions, loops, conditionals, and modular programming. We can write clean and organized code that's easy to debug and maintain. Why embedded C? Why do we need embedded C? First one, hardware access. We need to control hardware pins, sensors, and peripherals directly. But there is a problem with normal C. That is, standard C can't control I/O ports or pins directly. It was designed for desktops, not hardware. How embedded C helps? Embedded C provides support for registers and input output ports, letting us turn devices on and off or read inputs directly from the pins. Second one is small memory. C programming assumes plenty of memory is available and does not optimize for small sizes. But embedded C is optimized for very little memory, so programs can run smoothly in tiny microcontrollers. Real time tasks. C has no built in timing control, so we can't accurately manage time sensitive operations. But embedded C supports timers, delays, and interrupts, enabling real time performance. No OS support. C does not support OS libraries, but embedded C is designed to run directly on the hardwares without any OS dependency. Customize hardware. Normal C does not support microcontroller headers or MCU specific features, but embedded C uses MPU specific headers and specifications to work with custom hardware configurations. Now, introduction to the PIC16F877A microcontroller. This is a 8-bit microcontroller developed by the microchip technology. It is a part of the PIC16 family and it's widely used in education, automation, robotics, and consumer appliances. Why do we choose this microcontroller? First, it is very easy to program. Second one is it has multiple input output pins, built-in timers, ADC modules, USART, and PWM features, all of which are ideal for simulating a washing machine. It also supports interrupts, allowing us to handle real-time events like switch presses or motor status. Using this big microcontroller, we could easily interface components like LCD, buzzers, switches, and simulate actual washing machine functions just like a real-time system. Now I am going to explain about the architecture of this PICSIMLAB. Here is the center block PIC16F877A. This is the heart of the simulation. It is an 8-bit PIC microcontroller from the microchip. It controls all the input and output devices shown in the diagram. It communicates with sensors, display units, and keypads, and other communication modules. On the left side, we are having GPIO, I2C, EEPROM, and temperature sensor. These are the inputs which we are giving to the microcontroller. GPIO, these are the basic digital pins we use to read or write to external components. It can be used for buttons, LEDs, relays, etc. Next one is I2C, RTC, EEPROM. Communication, it is used for communication using I2C protocol. RTC is used for timekeeping. EEPROM is used for non-volatile data storage. LM35 temperature sensor, it is an analog sensor. It outputs voltage linearly proportional to the temperature. PIC reads this using its ADC. ADC converts analog inputs to digital values the PIC can understand. It is useful for sensors like potentiometers, light sensors. On the right side, we are getting the outputs from PIC16F microcontroller. First one is RS232. It is a serial communication protocol. It is used to send or receive data between microcontroller and PC or other microcontrollers. LEDs are used for output indications. PIC can turn LEDs on or off based on the program logic. Buzzer provides audible signals. It is controlled through GPIO and it can be used for alarms or notifications. A digital keypad is typically a small number of keys which are from 0 to 9. It is used for numeric input to the system. SSDs means 7 segment displays. These are used to display numbers or characters. PIC sends signals to light specific segments. Matrix keypad. It is a larger keypad in a grid format like 4:4. It allows the entry of more characters or commands. CLCD. It is typically a 16 cross 2 or 20 cross 4 character display. It displays text messages or sensor values. It is controlled using data and control lines from the PIC. Thank you.
My name is Yamni and now I'm going to present the simulation part of our project. Our project is titled as Washing Machine and Embedded System Application. So far, my teammates have already given you a detailed explanation about the embedded systems, their application, and also how we write programs using embedded C. Now, I will explain how we applied all of the knowledge into our project, and I will also give you the live demo of our washing machine simulation. As a part of the EMERTXE internship, we designed and simulated a basic model of a washing machine using PIC16F877A microcontroller. Washing machines are one of the most common and useful embedded systems in our daily life. To implement this project, we use the tools like MPLAB XIDE, X8 compiler, and PICSIMLAB. MPLAB XIDE is used to write our embedded C code, and X8 compiler is used to convert the code into machine code for the microcontroller. Meanwhile, PICSIMLAB is used to simulate the working of the washing machine visually. In general, we already know that a washing machine is an electromechanical home appliance that is used to clean clothes automatically without requiring human effort. It uses a combination of water, detergent, and mechanical movement to remove dirt from the clothes. In technical terms, a washing machine is a real-time embedded system because it performs multiple operations based on inputs and give output like spinning, washing, or rinsing like that. It consists of both software and hardware which work together to perform the washing effectively. In real life, washing machine operates in different modes depending on the types of cloths like daily, heavy, delicates, bed sheets, cottons, eco-friendly, like that. Each program includes three basic stages like wash, rinse, and spin. In our simulation, we included all of these programs and designed based on that only. We wrote the logic using embedded C, and we control everything using switches, LCD, buzzer, fan, like that. If you clearly observe, these are the functional requirements of our project. For our project, the inputs are taken as the switches like power on, pause or stop, navigation, door status. These are the inputs. In power on, we use it to give the power to the microcontroller. Meanwhile, pause or stop will tell the washing machine to work or to pause for some time like that. Navigation is also used to related to that only. Door status, it checks whether the door is open or not. If the door is open, it alerts the user by using the buzzer. And the outputs of the microcontroller are considered as CLCD, buzzer, and motor. Here, since the washing machine requires motor to run, in PICSIMLAB we consider the fan as a motor. By using the CLCD display, we display the washing status. Since it is a simulation, we use it CLCD. Next, the mainly the requirements of our project washing machine. For our project washing machine, we have mainly six screens to display in a CLCD. First screen is power on screen. The When we give the power to, when we start the microcontroller, the power on screen will on by using the switch 5, and the washing machine should be started. So when we press the switch 5, the washing machine should start simulating. And the next screen, washing program screen. For this washing program screen, we use to switch 4. This switch 4 indicates the types of modes or cloths like I mentioned before, daily, heavy, delegates, whites, like that. It shows different types of modes. To see different types of modes, here we use switch 4 to scroll. Since we use CLCD 16 cross 4 only, we have only availability of 4 lines only. So we use scroll. If we press the switch 4 for short time, it scrolls. To select to select that particular mode, we need to long press the switch 4. And when we long press the mode, then automatically it goes to the water level screen. In water level screen, we have three modes. We have five modes like auto, medium, low, high, maximum. These are the water levels used for the washing. It is similar to the previous washing program screen. And then start screen. In start screen, we use switch 5 and switch 6. Uh, when the function or programming started, the switch 5 is used to move forward of the washing machine. If we pass the switch 6, it will again move back to the washing program screen. This is used when we pressed daily instead of heavy, like that. If in case any alternative options are chosen, then we use this switch 6 to get back to the washing program screen. And further one, function screen. This function screen shows what is the mode of the function and which function is going to do, like wash, rinse, spin, and it also shows the timer. In function screen we need to use three switches, switch 1, switch 5 and switch 6. Switch 1 will use to check the door status and switch 5 is used to start. This switch 5, this start condition is used when switch 6 is used. Here switch 6 is used as pause condition. When pause condition is used, then automatically next time we need to start the program, like we need to continue the program. For that situation, here switch 5 is used. After the completion of three functions, wash, rinse and spin, the timer will automatically become 0. Then the CLCD should display completion screen, like the program is completed, you should remove the clocks. These are the requirement of our project. Next one, let me show you the project demo. Clearly observe, this is the PIC16F877A microcontroller. Since in PICSIMLAB we have various type of microcontrollers and boards, to select these microcontroller we need to follow some certain rules. In board we need to select PIC Genius, and in microcontroller we need to select PIC16F877A, and also we need to maintain the clock frequency as 20 MHz only. Since we are using 16 cross display, we should select 16 cross 4 display only. In PIC16F877A, we have 7 segment display, switches, push buttons, LEDs. These all are inbuilt in this microcontroller only. For our requirement, we use it CLCD, switches, fan, buzzer, and that's it. Let's go through our demo. First, we need to power on. To power on the washing machine, we need to press the switch 5. Since RB4 is a switch 5, let me press this. If you clearly observe, when I switch the press 5, the washing machine will start powering. After the power on screen, we get the washing program. In washing program, we are getting the all type of modes. If you clearly observe, daily, heavy, delegates. Here, if you clearly observe, I am pressing the switch 4 only for the short time only. Like this, we need to scroll down and select the required mode. Let me select daily. To select, we need to long press. After selecting daily, we are getting the water level. We have water level in 5 types: auto, low, medium, high, max. These are the water levels. Here I am going to select the auto. After selecting the auto, we need to start the washing program. For that, we need to press the switch 5. Here it's showing the mode is daily and the time is 41 seconds. The program started and the 41 minutes, here we consider the minutes as the seconds only, since it is a simulation. Here if you clearly observe, wash function is simulating. As I already mentioned previously, in here it changed to rinse. To pause, we need to use switch 6. If you clearly observe, here switch 6 is pressed, so the program and the working process has paused. Here if you clearly observe, the wash program is changed to rinse as per the given type of cloths or given type of mode we are using. After some of the time, it will goes to spin. Like that, based on the requirement, we are manage the code to run the washing machine efficiently. Since I said previously, in function screen we have 3 type of switches used. Switch 1 is used for the to check the door status. Let me check that. Here I paused the program, that's why it has stopped. Again I restarted it. Due to some delay, it takes some time. Yeah, if you observe this, here it again started. Let me check the switch 1. Here I press the switch one, so it shows the door is open, please close the door. If we release this, it automatically continues the function. In this way the process will continue. If you observe here, the rings again change to spin. After the completion of spin, we will able to get the program completed, remove the clothes, and the washing machine alerts the user by giving buzzer alert. After that, it again move back to the washing program since the program got completed. This is a demo of the project. If you clearly observe, we all already get the all outputs. The first one is the to powering on the washing machine, and the second one is the screen when the washing machine is powering on, and the third one is the washing program screen, and then water level screen, then start stop screen, and function screen, and the door status screen, and at last the completion screen. In this way we follow a manner and how the washing machine will work. Once if you clearly observe, once all the steps are finished, the completion screen appears and shows that the program completed and remove logs. To conclude this project, we learned about embedded systems in a practical and interesting way, and we already have an idea, get a detailed idea about the embedded C programming, big controller, and output components like LCDs, buzzers, and also interfacing with these all components. This internship and simulation experience gave us the confidence to design and implement the embedded systems project on our own. Overall, it was a great opportunity to learn how devices like washing machines operate internally using embedded programming. Thank you for giving this opportunity.